Hey everyone, welcome to Nullcon webinar. As you know, we are Asia's largest conference, and we have exhibitions and we provide training to all the cybersecurity enthusiasts and experts. And we have been running a lot of webinar, resume clinic, and training on our Nullcon platform. And we continue to share the knowledge from all the industry experts. This month, we bring to you two such webinars that would give you a sneak peek into our upcoming Nullcon online training. And one of them is Geoffrey's rapid threat modeling prototyping for Agile and DevOps. And the next one would be hacking modern desktop apps with XSS and RCE by Abraham, and which is on 23rd of October. And we have a Nullcon online training coming up on 7th of November with all the four interesting topics to cover on. So going ahead with Geoff, Geoff has a great experience. It's been like 3 decades he's there in the industry. Okay, and he's the creator of open source rapid threat modeling prototyping, which we're going to see today, and he's going to talk about. And as a global technology leader, he's seen software design to development and security consulting to been to large scale enterprises like Cigital, Bank of Finland, Sony Mobile, Visa, etc. So yes, so it's a thrill to have him here, and we will start with Geoff now. And over to you, Geoff. Thank you for joining in here.
Thank you very much. Anyways, yeah, there's a circle around my face. That's me. Just in case you notice that I've got a beard right now, thanks to COVID. And well, welcome everyone. I hope that you guys are going to enjoy the next 30 minutes. I'm going to breeze you through the rapid threat model prototyping, and I'm going to share up my screen. It's going to give you kind of a few touch points, some ideas on how the whole RTMP works, and then I'll entertain a few questions at the end of it. So without further ado, let me share up my screen and let's carry on. Let me just, here we go. There never seems to be a decent way of doing the switch, does there, unless you're you have thousands of pounds or thousands of dollars worth of equipment. So hopefully everyone can see the screen right now that I'm showing, and I'm showing the intro screen, and let's carry on. So this is open source, so you guys can go ahead and grab it, use it, mangle it, manipulate it, fork it, I don't care, have fun with it. Now, you guys are probably all wondering, who am I? Well, all right, I can tell you. In the mid-1990s, I ran around the world, and I was a developer at various places, just kind of making some money and then going on to the next place and all that right there. That's why I have my 3 decades worth of experience, because I've been running around the world, basically having fun, but also developing and doing security on top of it. So here we go. Now in 2002, I got hired by Microsoft, and I jumped right into security right there. And they have something, the Microsoft SDL, which is the software development security development lifecycle. And it sits on top of most SSDLCs, which are secure software development lifecycles that most companies use, but now are shifting over to Agile. So in 2002, we didn't really know much about Agile, but in 2004, people started to shift into Agile and started to try to find a new way of working. So the SDL had to adapt, and we had to adapt with it. At Visa Europe also, as mentioned, I worked at Visa for 4 years as the sole AppSec architect in Visa Europe, not in Visa overall. They have tons of AppSec architects. And I basically started working on attack chains and all that right there. And I worked on some very sophisticated threat models to help them out with some very sophisticated software that they had in the background. And finally, I'm the founder of Tutamantic, and Tutamantic is a threat model automation software. So you can find out more about that looking. So let's go for the 4 points of what we want to talk about in this webinar here. What does threat modeling do? What it doesn't do, and that's a big hole. Why, and that's why we came about to having the rapid threat model prototyping, an overview of secure Agile architecture and how it fits in, and finally, the introduction to rapid threat model prototyping. It's just going to be an introduction though, so it's all kind of skimming over, but it'll give you a flavor of what all these are. So what should threat modeling do? Well, in a good world, in the theoretical world, threat modeling should cover 3 points right here, and they're the core security concepts: secure by design principles, secure by default principles, and secure in deployment principles. So if you look at those in detail, secure by design principles talks about defense in depth. Threat modeling should enable you to put defense in depth in any one of your applications out there. And you should be able to have an application that doesn't just define itself by defenses on the perimeter or anything like that. So it should define that. Second thing that good threat modeling should take care of is it should cover the principles of identity and least privilege. Now, identity is who I am. So it should know or should identify if there are any anonymous or if there are any misidentified entities trying to access whatever it is that you're creating. And the principle of least privilege. Least privilege states that you shouldn't have more permissions than what you need to have to get the job done. Anyone out here who's taking this course has probably run up against it. One of the biggest least privilege issues has been access to databases, for example. In the bad old days, they used to say, hey, no problem. We'll just give everyone DA privilege, administrative privileges on the store. And what would happen is people would use its admin privileges and they basically hop into the underlying system as admin. So that's why you don't want to give entities too many privileges. And then finally, secure and deployment. And secure deployment has two aspects to it. The endpoints and ports, you want to know what endpoints you're communicating through, and you want to know what ports you're communicating across if you're going down that low. And finally, and very important right here, is what communication protocols are you using to communicate to other entities? A lot of communication protocols, in fact, most of them have some weaknesses in one shape or form. So you need to know about this, and threat modeling should bring this out. Finally, great. Now, threat modeling should also take care of everything you see in this diagram right here. This diagram is an old ISO diagram, but I think it kind of lays things out quite intelligently. So you have threat agents which drive the threats. The threats influence the risks, vulnerabilities, and they also influence the countermeasures. You have owners in the upper left-hand corner who obviously want to protect the assets, and they're going to take care of that, and they're going to look at the risks. Now, the risks is just a measurement. It's a business measurement on how many attacks potentially can happen against the assets or how badly exposed the assets are. So they're directly related to the number of vulnerabilities and the number of threats out there. The difference between the threats and vulnerabilities are pretty stark. A vulnerability exists. A threat, it may exist. We think it may exist, but we haven't proven it yet. So what we'd like to get doing with threat modeling is that big red arrow. We'd like to have a one-to-one relationship with threats to countermeasures. So each threat that we have should have at least one countermeasure associated with it. Threat modeling should also expose flaws versus bugs. Now, flaws, on the one hand, are something that you build into the design, and then every instance of that design will expose that flaw. Whereas a bug will be that the design is done well, but the people who implemented the design made some mistakes along the way, therefore bugs. So the two things right there are quite different. And you want to take the threat modeling, you should say, we want to look at reducing the amount of flaws that we have in a design. With the bugs, well, we're going to reduce some of them, but threat modeling is not really doing that. Threat modeling doesn't talk about the actual instances. It talks about the design, the template, the structure, if you will. So with threat modeling right here, we want to understand a number of things. And this is a basic threat modeling process that you're looking at. And it has 4 different steps to it. 1, you model design. 2, you analyze the threats. Then you analyze the mitigations. That's down at the bottom right there at 6 o'clock. Then you validate the threats and you validate the design. And then you go back and you reassess your model. And so it's a continuing process right there. So in many ways, threat modeling is very focused where it can be used in an agile manner because of this 4-way process right here. So in modeling the threat model, you want to understand 2 things about it. You want to understand what the zones of trust are. So where do I hold trust and where don't I hold trust? And the other concept you want to understand is dependencies. What other applications or systems are dependent upon my model? Because the more dependencies you have, then the more problems you have down the road if you find an issue. If you have a particular issue that gets coded in as a bug or as a flaw, and you have about a dozen dependencies on that, it's going to be very difficult to fix that bug without breaking a lot of things. So that's why threat modeling is very important, is it should point out these dependencies. It should be making everyone aware of what the dependencies are. So we go into analyzing the threats. So the best way to analyze threats is you use a common threat framework out there. You don't make up your own. Then you have to maintain your own threat framework. And there are plenty of good threat frameworks that exist out there currently. Stride is one of them. That's a very simple one. CIA is a very, very simple one. It's only 3 letters. And then you have other ones such as the OWASP Top 10, which is not necessarily a framework. It's more of a teaching tool, but it can be used as a framework. And then you have the MITRE frameworks, MITRE. So MITRE has things such as common weakness enumeration, CAPEC, which is common attack patterns, et cetera, et cetera. You look for security control mismatches when you're analyzing the threats. Where am I not covering my design with controls? Those threats are now exposed, and those threats are potential big danger points. So we go on and we say, okay, we're going to analyze the mitigations that we've applied using our threat framework and our security control mismatches. And we're going to do one of 2 things. We're going to either accept that issue or we're going to try to reduce that issue in some way. So we try to reduce that issue by using security requirements, put them into the design, put them into your patterns, and move along. Or if we accept them, which is generally a less preferable way of doing things, there's a lot more of we're kicking the can down the road. So we have to make sure that we put this onto a risk register and we track those threats as they go through the life cycle. Finally, we're going to validate our threat model. And validating the threat model has 2 points to it that I'd like to bring up. One is we do static analysis code reviews, which is in analyzing the actual code that comes from the models you designed. And that's where you find your bugs. And then also doing a form of security testing. Security testing generally is where you'll take the output of the threat model as threats and you'll design a security test for each threat you found. If that test gets validated, then you haven't solved that threat yet. You haven't resolved that threat. So those are the ways you go about doing a threat model. Now, we told you what threat modeling should give us, but what threat modeling in the current environment actually gives us is a lot less. I don't know if anyone here on the call has been in threat discussions. I've been on a lot. And a lot of times you end up with people talking, gesticulating, yelling at each other, and they spend too much time trying to find out what the threats are in the threat model and not enough time spending on solving it, on finding the mitigations. And the problem with that is that we're not in the business of finding threats. We're in the business of finding mitigations. Because, and you might think, well, that's kind of counterintuitive. Well, it's not actually, because we want to go and we want to create better software. And better software means finding the mitigations to those threats. We want a fast way of getting to that point. So while we do want to find the threats, we don't want to spend too much time on it. We also have things such as messy data flow diagrams. Now, old threat modeling or the traditional threat modeling asks you to take a design and then to create a data flow diagram on top of it. And what happens a lot of times is people misinterpret what the design does, and the data flow diagram comes out to be something that doesn't really look like what the underlying design is. And you end up with a lot of trust boundaries that don't get really well defined. You have request response issues. You say, well, okay, they're split out. Maybe they shouldn't be split out. Maybe they should be treated the same, things like that. You have other things such as this design on the left, which I found. And I'd have to say, well, is that actually what the design does, or is that something different? Because once you start getting a threat model that interprets a design differently, then they start getting out of sync. And now you're going to need an expert to take care of interpreting the threat model. And then also you're ratcheting up the participation cost. And finally, with all that work right there, you have all the other things you need to do, and the threat modeling is just part of it. And what do people end up doing? People end up taking the threat modeling and put it over on the side and say, we don't have enough time to do this. And they end up not doing threat modeling. And it's unfortunate because threat modeling is a very powerful tool, because threat modeling gets done at the very beginning of the activities, when you're designing whatever it is you're designing, your system. And at that point in time, it's the cheapest to fix things, because all you have is you have a diagram up in front of you. You're discussing things with people and you're saying, maybe we should put a control here. Oh, maybe we should put a control here. Very cheap to talk about it and to put it into design. Much more expensive to do that once a design is built, as everyone would probably agree on this call. Now you come time for the final sprint and you haven't fixed anything. You're going live. You haven't finished your threat model. The threat model, or you finish it and you're going live and you realize you find a bunch of big issues and you can't fix them due to dependencies and due to the fact that you're going live. And that's unfortunate. So we don't want to be put in that position. We want to be doing our threat models back near sprint 1 or sprint 2, not sprint N. So we want to ground ourselves in what's called secure agile architecture. Once we ground ourselves in secure agile architecture principles, we can use the agile manifesto. You can use agile to do our threat modeling, and then we can apply more agile principles to our threat modeling. So what is agile architecture? I'll give you a quick rundown. It's got two parts to it. It's got what's called intentional architecture, which is what you see in the right-hand side right here. And the intentional architecture is a marriage between the business strategy and the technical enterprise architecture. And there are a number of different components that go into that. But essentially, once you get a strategic agile architecture program set up, it could be one person doing it. It could be people sharing the task, as long as they have a shared vision for what's going on in the company. And that shared vision, like I said, it comes from the business strategy. And the business strategy gets it from the vision, the business mission statements, and the business objectives and business goals. They all combine together to create a strategy. On the enterprise architecture side, you have to take into consideration what processes exist, what technology are we using, what information can we gather, what principles are we already using, what capabilities do we have within our company, like what kind of people, and what functionality do we have in a company to do this with. By doing this, we enable cross-team design, which means we can start sharing designs with other groups, and we don't have to start recreating the wheel each time we do something. And what you don't want to have is you don't want to have a flawed design with one team being potentially used by other teams. You want it to be a collaborative effort at the very top, and you want some direction, some strategic direction from the company on certain high-level designs. It makes it very easy once we use strategic agile architecture to map business objectives to our technical business requirements, which then can flow into the next stage, which is emergent design. Now, emergent design sits on top of the actual agile flow. So if you think of your teams, emergent design will sit on top of it and say, okay, look, at the beginning of a session, we have usually some sprint zero activities at the beginning of a programming increment. And at the beginning of our PI, we do some activity, and then we pitch in, we create our stories, and then we start pitching and we start doing our sprints. Now imagine if during that period of time you do some model storming during that time. So you basically say, okay, we're gonna threat model right now. We're gonna create a threat model of the design that we know about, and then we're gonna go in we're gonna create our user stories, and then we're gonna go in, and each sprint we're gonna do these other activities you see right here, such as iterative modeling. Each sprint we're gonna model just enough to get us along, just barely good enough. We're going to bring our architecture and visioning, which is tying ourselves back to that intentional architecture piece I told you about. We're going to do some look ahead modeling, because we're going to enable ourselves to create a variety of models and do what if analysis, essentially. What if we do this? What if we do this? And we're only doing it on models. Therefore, we can fail fast and we can go back to the beginning again. It's almost like doing a spike, but with threat modeling. So you're allowing yourself to do continuous integration. You're allowing yourself to enabling continuous testing. And then again, you're using those business requirements that you captured in the intentional architecture stage, and you're pulling them into this more closer emergent design stage, which wraps around the team's activities. Now there's something called SAM, which is a security asset market model. Sorry, security asset maturity model. And we'll go into SAM a little bit later, but SAM essentially says, we're going to take some security requirements, we're going to put them towards the maturity of our business. We're going to tie this to threat modeling. So each step of threat modeling is going to enable us to do more mature processes. This is SAM right here. SAM has 4 different high-level elements to it. You can look it up by going to OWASP SAM. And it's going to, again, completely open source. And essentially what you're going to be doing is you're going to be looking over 4 different areas of your company or your project. The governance area, which is how do we go about maintaining the compliance of this? How do we go about doing education on this? How do we go about doing metrics? The construction and verification are the actual build components. Construction is where do we think about? It's like the design part. So we figure out where our security requirements come from our business requirements. We figure out our secure architecture. Threat modeling comes into it. We do threat assessment. Again, that's pure threat modeling right there. Then we go to verification. Verification having 3 elements to it. Design review, which is pure threat modeling brought into the sprint. Now we're talking about inside sprint activities. We do implementation reviews, which are driven by the output of the threat model, the mitigations. And security testing, which is also driven by the output of the threat model, because security testing is driven by the threats that you find in the threat model. Operations then tails it off. Operations isn't really affected by threat modeling directly, but indirectly it is, because we might change our environmental hardening due to results of a threat model. So let's do a quick overview of rapid prototyping. Rapid prototyping has 4 parts. We identify the basic requirements. We have a conceptual design that we think in our head. We test this prototype, we spike it, provide feedback, revise, and enhance. Keep that in the back of your head because it's very, very much like what we do when we spike stuff in an Agile sprint or prior to an Agile sprint. We're coming up with the concept of rapid threat model prototyping, which is a concept that I came up with. And it has to have 3 things: a consistent framework, a repeatable process, and measurable data coming out of this. So it's perfect for CI/CD pipelines and for DevOps for that reason. The repeatability is key here. Now we want our prototyping to have several different issues. We want to start the conversation, but not necessarily finish it. We want to have the 80-20 rule, which is 20% effort gets us 80% output. We want to get just enough information to get us to that next step. Like I told you, it's the emergent design part of the Agile architecture. And we know it's not going to be comprehensive. We don't want it to be comprehensive. We want to build it as we go along in the sprints within that programming increment. Here's the introduction to rapid threat model prototyping in 9 minutes or less. So we'll break it down by DevOps steps. Let's start off with the planning stage right here. We want to communicate our issues across groups. During the planning stages is where we pick a common security framework, such as OWASP Top 10, we move along. Now, in our case right here, we can use Stride also. If you ever find Stride on the internet, you'll find it looking like this. Look at number 3, repudiation down there. Now, repudiation, say the opposite is non-repudiation, which doesn't make much sense. But if you think about it, repudiation says, I wasn't there, I didn't do it. So that means that you had poor authentication and you didn't have integrity on your logs. Therefore, the lack of authentication and integrity means that a bad guy can repudiate what they're doing. So let's walk through Stride. Spoofing. Spoofing is a lack of authentication or poor authentication on nodes. You can't tell what the identity is. Tampering of the data. Tampering of the data means you fooled around the integrity of the data. Generally, encryption can help with that, but obviously you don't want bad guys tampering with the data. Repudiation, we've already covered that. Information disclosure, that's looking at the confidentiality of the data. So if the data is not confidential, if it's not hidden, if it's not encrypted, then bad guys can glean that information to their benefit. We all know about denial of service. It's you want to keep it highly available in most cases. And the last one, the most important one, is elevation of privilege. That's authorization. So authorization or access control. Elevation of privilege can trump any one of the other parts of Stride here, because if I can elevate privilege in a system, then I can basically change things to my way. So the first thing we want to do is we want to stop elevation of privilege issues. So during the planning stage, we want to do some model storming. And during that model storming right there, we're going to get a very rough threat model coming up. So an example right here is we take an underlying diagram. This is an underlying diagram here of a real system. We take the underlying diagram, we use that, and we put security metadata on top of that instead of creating our own data flow diagram. As I said beforehand, command and control on the attack kill chain is the most important because that's elevation of privilege, because it's also access control issues. So if you look, for example, on the attack kill chain, the bad guy will do an initial attack and they'll attempt to gain command and control. They'll attempt to elevate privilege so they can keep on getting further into your system by spreading themselves. And they can exfiltrate data, they can maintain presence and everything like that. So the priority right here we want is command and control reduction, or access control, or reduction of elevation of privilege. So during the create stage, we're going to look at our security zones. We're going to say, look, we're going to define each element in the model as having a certain zone to it numerically to give us an idea of what's lesser importance and what's got higher importance. This way it allows us to find elevation of privilege issues quickly. And believe me, a team will know what its most important elements are that it's working on. I've done this dozens, I don't know, maybe hundreds of times. And each time the team has been very good of finding its most important bits and its lesser important bits. So guidance. We want to build defense in depth, focus on the diagram design. Any inbound communication is outside of our diagram's control, outside of our design's control. It doesn't matter if it's coming from inside the company or outside the company. And zones should be valued between 0 and 9 to help you out. Don't go crazy. You can make a zone 50, which means it's very, very high in terms of the trust, but it might not help you. I mean, 0 to 9 helps. So for example, on this diagram right here, these two external parties on the left, I would designate as zone 0. They're outside of my control. The website, zone 1. That's inside my control, but it's on a boundary. Same with the API gateway. And the other ones right there, you'd fill out. In the upper right-hand corner, you've got a queue. You might designate that as zone 7 or 8 or 9. And then you've got 3 data stores. Those 3 data stores will most probably be 8 or 9 in value because they're very high. So for example, right here, what I did was I said the results data set is 9. The blob storage I said on the lower left-hand right there is 8. And the analysis rules, which are usually static, a 7. I didn't give them that high. I said, well, okay, they're important, but they're not as important as the actual data and what's stored in the blob. I said also in this point right here, the website and the API gateway, they're zone 1 because they're on the boundary. Okay, and then everything else falls in between. As you can see, all the other entities falling in between. So applying the zone rules. So I have a number of rules, one rule for each of the stride mnemonic. I'm not going to go into detail about these because we only have a few minutes. This is only meant to be a kind of a precursor, but the rules will kickstart your analysis. And let me show you. So you have an elevation of privilege rule, which is found by the difference between the zones. You have spoofing rule, which is again, difference between the zones. You have tampering rules on the data flows, which are difference between the zones again, going from low to high. So you can usually tamper with the data. Repudiation rules, which says that if it goes, it's on the target element, if it goes where spoofing and tampering exist, then you're going to potentially have a repudiation attack, which means that the attacker is going to try to cover their tracks. Information disclosure threats are only a few of them in this diagram, and those happen to go from high value to low value. So we're all working on the zones right here, and the zones are discovered by the team themselves. Once you figure those out, you run some simple rules on the rapid threat model prototyping to get the actual threats. Once you finish with the threats, denial of service, then you go through, and after that right here, you sort out the mitigations. So that actual step is going to be fairly quick. The next step right there is to go find the mitigations. And the mitigations are going to come generally from a mitigation list. So we get the threats right here, we put them into a risk register such as a threat database, Jira might be an example, or anything like that, and we generate automated test cases with our threats. Now this is the important bit, mitigations. We get to that. Now we don't want to discover the mitigations, we want to have mitigations written out for us. So I encourage everyone who's on this webinar right now to go look at Stride, go look at CWE. CWE and CAPEC are both products of MITRE, M-I-T-R-E, and they're huge lists, and they're very comprehensive. So if you can find a mapping between Stride elements in CWE or OWASP Type 10 in CWE, then you can find a huge amount of information which you don't need to recreate yourself on all sorts of weaknesses, which then you can turn around and you can fix in your threat model. That's why I strongly recommend, I can't recommend enough, to use those taxonomies, to use those frameworks instead of generating your own. And then you put the output to a sprint backlog. So tampering flow mitigations, for example, TLS and constraining I mean by reducing or limiting the amount of input that come in, therefore you can constrain what the attacker can do. You send the threat model information out to the pipeline, okay, in JSON, XML, CSV, any consumable format, and potentially what we're working on, one of the current jobs I'm doing is we're working on pull request merges where we can stop the pull request from happening on code if we discover the threats haven't been covered. So then we report it during the release. So we attach data to release notes automatically again in human readable formats if we want. We can automatically attach this in our release notes from the threat model output. We can then go and we can look at risk tools. We can look at Splunk, the Elk Stack. We can take the output of all of our threat models because they're done in a machine readable output. We can put them in and we can have them ingested further down the pipe with other tools. And then we monitor. Monitoring means we look at what the risks we found, we look at the threats we found, how have we fixed those threats? Are vulnerabilities popping up where they shouldn't be popping up? So I know I've done a super fast run by here. It's half past right now. You can find more information on my GitHub. That's what you type in, GitHub Rapid Threat Model Prototyping. And also I strongly encourage you to take my class because I do this 30-minute bit in actually several days, which makes it a lot more relaxing for everyone and a lot less stressful to go through. So 5 key takeaways and I'll hand it over. Problem traditional threat modeling, Agile architecture and how it can be used for threat modeling. We refine Stride so we could use it. We find our elevation of privilege issues quickly, and we go over the rapid threat model prototyping, although a very, very fast move. Thank you.
Thank you, Geoff. It was quite rapid, actually.
A rapid talk on everything. Yes.
It was absolutely insightful, and I do believe it was for our attendees as well. So if there is any question for Geoff, we have 10 minutes open for you guys. So put in the chat box and.
Okay, so I have a few questions here, I guess. So what is the best way to convince business development teams to go for a threat modeling that helps in mitigating the risks at early stage in life cycle? You might have come across some situations in the past where you didn't get much attention, cooperation from the development teams in gathering the information required to build threat modeling. How did you overcome such situations? And that's from Gopal. Okay, so the best way to convince business and development teams is to tell them you want to talk about the dependencies, you want to talk about the amount of time that a development team takes to fix bugs they've discovered late in the development lifecycle. So I'm sure that everyone on this call right here has encountered a situation where you're about to finish with a sprint, or even worse, you're about to go live, and you find a particularly nasty bug, and you have to pull people off from other projects who've been moved to other projects, or from other work they're doing to help you fix a bug because they were working on the original code. This means they're not doing what they should be doing. They're fixing this bug, means that all sorts of people are taking up this time, because it's not only you, it's the developers, it's potentially testers. You might pull in some scrum masters and project leaders. You get a lot of people involved in fixing these issues. And if you fix them late, it costs a lot of money, not just in the time that you spend, but potentially in buying other kit and buying other tooling. So what threat modeling does is it preempts a lot of that, because if we're going to look at the design, think of it as like designing a car. If you designed a car without any brakes, what would that do? You design it with a big fast engine and no brakes, and somebody gets out there on a road and drives it, realizes they can't stop. That's a bad time to find that. So what you want to do is you want to be finding out that there's no brakes when you're designing the car, because it'll cost you a lot less to put in brakes into a car and put it into the design. And that's effectively what we're doing. It's to convince them. You say, look, it's going to cost you guys a lot less time if you spend a little bit more time on getting a proper design. Another idea would be like creating buildings, high earthquake zones. You know that they've got architects who spend a lot of time creating buildings with springs on them and it's amazing what they do. The reason they do this is because they don't want those buildings to fall down at the sign of the first earthquake, because that's a lot of money spent and a lot of destruction. We don't want that. So threat modeling is kind of the equivalent of putting those springs in and assessing that design before you actually go out there and do the hard work of developing. Hopefully that has answered your question there, Gopal. I've got a question from Mayank right here. And Mayank says, often we are in situations where we want to establish a process for threat modeling, but one of the major concerns is what to do with the existing pieces that may have been developed in the past. Aha! The easiest way would be to treat them as black boxes and focus on the new design. Do you have a better approach? Unfortunately, no. We tried one time. To give you a little bit of a story, we decided we were going to go down, we were going to threat model everything. And we started threat modeling TCP. And at one point in time, this is way back in the day, and don't do that. Okay, I don't ever do that, because we went down a rabbit hole and we spent a lot of time and a lot of arguments getting nowhere. So where you can, you need to grandfather things in. And so that would be grandfather would be treat them as black boxes. If they're simple, yes, threat model them. I encourage you to. If they're complex solutions, you probably will end up having to say, look, we have some knowns and we have some unknowns. And the knowns that we have are certain weaknesses with this application. We're not going to delve into it. Therefore, the application is old. We're looking to move this application off, hopefully isolate it. Hopefully, you'd be looking to introduce new software or new processes that would take the place of that application. And therefore, you'd be able to move over to that. If not, if it's fundamental, if it's critical to the software you have and no one's going to move it, then you might end up having to dig into it and do threat modeling against it. Now, I recommend doing stride analysis, and the stride analysis is fairly quick. It's on the rapid threat model prototyping. Get a high-level idea of what it is that you want to do, and then don't drill into details, and try to get as much information as you can in a short period of time. And that hopefully will reduce the pain of the black box situation. Okay, I hope I'm saying this name correctly. It's Murtuja?
Yeah, Murtuja. Yeah.
Murtuja. Sorry, Murtuja. Apologies for that. So Murtuja said, most of the threat modeling reports are very difficult to understand. Don't I know? Especially mitigations are not very clear. I'm curious to know the rapid threat model prototyping report looks like. It's very simple. The rapid threat model report looks like a diagram with some symbols on it and references to the common weakness enumeration. We want you to do the minimum amount of writing up stuff as possible, because the more stuff you write into a report, the more confusing it gets. We want it to be very clear. We want you to put it down in a diagram so you can see in the diagram, diagrammatically, where the issues lie. I mean, we're all graphical creatures. So I don't know about you guys, but I'd much rather look at a big picture than I would look at like a 40-page document written in tiny script of what the different issues are. Personally, I would rather do that. You want to come to, again, you want to come to the solution faster. So the reports, the reason that the reports are difficult to understand is because security people wrote them, and we're horrible about communicating this to people. So one of the things I encourage you guys to do is, if you make this as part of a team exercise, the team will write the results of the report up with the help of the security person, that's me, and the help of the security champion. I don't want to be writing the documents up, because I'll write it up in security gobbledygook, and then people who aren't security people will not understand me. Whereas if the people in the teams wrote it up, they'll understand. Like, yeah, we get it. We understand. We wrote this stuff. And that's how I would approach it. Any other questions? I'm enjoying this. We got about 3 minutes left. So anyone got any stupid questions to throw at me? There are no stupid questions, just stupid answers like mine. So and who's like hanging right now to go on this course? I'm sure you all are. This is going to be a fantastic course. Listen to this guy. I'm going to tell one thing. I'm going to tell plenty of anecdotes about my past, what blew up, what didn't blow up, to get you guys to avoid the problems that I ran into. One of the biggest things that I found frustrating about a lot of classes that I took in the past is they told me theoretical stuff. They never actually said to me, well, you know why this doesn't work? You're like, why? Because it didn't work with me. We had an entire project blow up. I try to tell these stories. I try to tell what didn't work and why it didn't work to help you guys avoid that in the future. I will delve into Agile practices. I will delve into DevOps practices and experiences. I will touch upon Agile architecture. Strongly encourage everyone who's going to attend the course to read up on Agile architecture, because it's not an Agile architecture course, but I will pull it in. And of course, look at the rapid threat model prototyping. Look at other threat modeling paradigms too, and see how they fit in. The rapid threat model prototyping is designed to find and create a threat model in as quick a way possible. It's going to be rough and ready. It's not going to be 100% perfect product. We don't want that. Any other questions? One of the things very strange is the whole feedback. It's like in a classroom, you're out there and people will feed it back. In a Zoom call, I've got a bunch of people's names, and you can't tell if people are like, wow, man, this guy, what is he talking about?
Well, Geoffrey, we do have one more question for you.
Okay. Yes.
So Sukumara is asking a question which says, how do you see MITRE framework from a TM perspective? Does this cover all aspects of design?
Very good question. So from MITRE actually has a number of different products to it. And CWE is one of them, the common weakness enumeration. Then another one is the CVE, which probably most people are familiar with, which is a common vulnerability enumeration. Then there's CAPIC, which is common attack patterns. And there's a whole bunch of other ones which we don't want to talk about because sort of strange words like taxi and God knows what like that. We'll leave them to the side because they're not as popular. Finally, there's the attack framework, ATT, and then the ampersand CK. That's a very, very strong one because it uses the attack framework and it uses actual attacks. So how do we go about, does it cover all aspects of design? I think it does. The CWE is very good. The CWE covers a huge amount of attack patterns. And in fact, you can do a mapping. In my class, you'll do a mapping from STRIDE, the STRIDE mnemonic to the CWE, and STRIDE to the OWASP top 10. Now, what that'll allow you to do is it'll allow you to take a 6-element attack framework and bolt it into the complete CWE with very little overhead and work. Now, also, you can map it to the OWASP top 10. OWASP top 10 automatically maps to the CWE because they do it for us. And therefore you have your entry into a tremendous amount of information, which goes all the way up to design principles. If you look at the CWE has a page, I can possibly look for it. Well, I'll probably spend more time trying to find it, but look at the CWE and there's a page right there which shows you a number of different lists. These lists show you design lists, they show you architectural lists, they show you lists that map to the OWASP top 10, to the SAMS top 25. Depending upon what you want to look for, it'll show you a particular list, which will show you a cut of the CWE. The CWE itself, I think, has several thousand elements to it. So you can get lost in it. I did. I've gotten lost in it beforehand. It's got a tremendous amount of information. Each element in the CWE will tell you its ancestors, will tell you its children, will tell you what it's related to, will tell you its attack pattern to look out for, will tell you what stage to expect that to happen, the weakness, and will also tell you what mitigations you can apply and references. So without you doing much of anything, you get this huge pool of information. You tie it back to the OWASP top 10, tie that back to Stride, and now you've got this huge pool of information available to you when you do your threat modeling. So yeah, I think that's about it. Hopefully I've answered his Sukumatra's question. Sukumatra? Sorry. Sukumar. Apologies. So hopefully I've answered Sukumar's question.
Yes.
Okay, good.
So
thank you.
If there's any more questions, we can take it one or two maximum.
Someone honked their horn.
All right. So I think there are no more questions, but you heard it from Geoff, everybody, that if you're attending his training starting on 7th of November, read about Agile, and you're gonna just get some more deep insights in that course. And I hope you enjoyed today's webinar. And thank you, Geoff, for this rapid webinar with your
rapid webinar about rapid threat model prototyping.
And yeah, it was definitely insightful. And to be honest, by going through your profile of 3 decades, I was just scrolling through. I mean, you have great amount of experience. So guys, you're gonna enjoy the training by Geoff. And then thank you. And now next webinar would be on 23rd October, which is on hacking modern desktop apps with XSS and RCE by Abraham. Please join. And he will also be there for our Nullcon online training. So thank you, Geoffrey Hill, for joining. And yeah, we will see you.
Have a great weekend, everyone. Have an enjoyable weekend.
And stay safe. Stay safe.
Exactly. Stay COVID safe. In these very strange times, stay COVID safe.
Stay COVID safe. Yes.
COVID safe. COVID
Thanks,
safe,
guys.
Yes. Thank you.
Geoffrey.
I'm Sparsh, and I'm signing off from there. Thank you. Thank you, Geoff.
Bye.